Hi everyone. We're going to wrap up this semester, this whole course with the last section, which is 13.4, which is where we're going to talk about velocity and acceleration using vectors. And so, especially if you've seen this in physics and such, you probably already know how to do most of this stuff anyway. So we won't spend a whole lot of time on it, but I'll just show you basically how it works with a few graphs. So your velocity vector would be your derivative of your vector function, very much like the derivative of a function in Cal 1 would tell you your velocity. The speed is the magnitude of that velocity vector. Remember, speed and velocity are not necessarily the same thing. And acceleration would be the second derivative or the first derivative of the velocity function. And so this says to find the velocity, acceleration, and the speed of the particle at which the given position function, sketch the path of the particle, draw the velocity and acceleration vectors. I'll show you, hopefully, what this looks like. Not too terribly bad picture. And we're going to have r is negative 1/2 t squared and t at t equals 2. So I'm going to find all the functions and things first. So remember, your velocity would be the first derivative. So you just take the derivative of this. Negative 1/2 times 2 is just negative 1t, or just negative t, and the derivative of t is 1. The acceleration is the second derivative, and so this would be negative 1, 0. And the speed would be taking the velocity function, it's the magnitude of the velocity. So I'll do the square root of t. Oops, that's a t. Doesn't look like a t, but we're going to go back and fix that to make it look more like a t. The negative t squared. Oh, I've got the parenthesis. I'm not doing too good right here, am I? Negative t squared plus 1 squared. And so we'll end up with just t squared plus 1. Please don't make that t plus 1 by taking the square root of each one of them. That is not the same thing in the least. So just t squared plus 1. That is your velocity, your acceleration, and your speed. And so it says to draw what this would look like. And I'll give you kind of a rough sketch of what's going on here. Remember, we mentioned this back in chapter 10. If you have a t squared on one of your components of your vector and a t on the other one, you're probably going to get a parabola of some sort. That's what we get here. My r, my original vector function, if I pick different values for t and x and y, plotting those points, I need to go through t equals 2 anyway, so let's just go 0, 1, 2, and 3. So if I do 0, I'll get the point 0, 0. If I plug in 1, I'll get negative 1/2 and 1. If I plug in 2, 2 squared is 4, half of 4 is 2, so I'll get negative 2 and 2. And if I plug in 3, 3 squared is 9, so I'll get negative 9/2, which is 4.5, and 3. So looks like we're going to be living pretty much on the left side of the axis here. And the numbers that I picked are all going in the positive direction, so we'll do the positive direction only. So I have the point 0, 0. That is right here. The point negative 1/2, 1 would be about right here. The point negative 2, 2 would be about right here. 9/2 would be 4.5. 1, 2, 3, 4.5, and up to 3. It's about right here. And so we're going to get a parabola kind of shape, kind of going down this direction like that. Since we are increasing our t values from the origin off to the left, our arrows are going to go this direction. And so that is my r, my vector function. It wants me to sketch the path of the particle, that's what the r would be, and then draw the velocity and the acceleration at t equals 2. And so for the velocity, that would be the negative t1. I have to plug in this 2 down into here, and so I'll have a velocity vector at 2, which would be negative 2, 1. Yeah, okay, sorry. I thought I was messed something up, but never mind. Negative 2, 1. And so my velocity, remember, that's kind of like your slope. And so this would kind of be like your slope being a negative 1/2, or 1 divided by negative 2. So going off of the point when t is 2, t is 2 is the point, t is 2 is this point right here. And so we would go, it would be down 1 and over 2, but we have to go the other direction because we're moving the other direction. So we have to go kind of up 1 and to the left 2. So up 1 and to the left 2. So up 1 and to the left 2 would be about here. And so I end up with a vector, my velocity, going up this way. That should be a straight line, by the way. My acceleration, the point negative 1, 0, tells me I have no slope, basically. So if I do, let me do a different color here. How about the dark blue? My acceleration at 2 is still negative 1, 0. So I'm basically going over 1 in the negative direction, but not going up or down any. And so that particular graph would look like this, just a horizontal line coming off of there. Now, I'm not the best with the pictures and the graphs and things like that, and so most of the ones I won't be doing any pictures for, just because, especially when in the 3 space, they look awful. So hopefully that makes some sense, but the more important thing is, can you find the velocity, the acceleration, and the speed? And I don't know why I put a prime right there, so we're going to get rid of that prime. So that's what we're going to do on these. Find the velocity, acceleration, and speed of the particle. So your velocity would be r prime of t. So I just take the derivative. You might remember we did this exact function in the previous section. So this would be root 2 I. The e to the t doesn't change. And the e to the negative t would become negative e to the negative t. Okay. There's my velocity. My acceleration is the second derivative. And so root 2i, that would just go away because square root of 2 would go to 0. So I'll just get e to the t j and a plus e to the negative t k. That's my acceleration. My speed, now notice this is not at a particular point, this is just in general. So that is the magnitude of the velocity. So I would do the magnitude of the velocity as the square root of the 2 squared, e to the t squared, and negative e to the negative t squared. In fact, if you remember from the previous section, we did this exact thing. This is 2 e to the 2t and e to the negative 2t, and I said you might notice that this factors. You might want to rewrite it as e to the 2t plus 2 plus e to the negative 2t to make it be in the correct, decreasing order. But this is actually e to the t plus e to the negative t squared, or this is just e to the t plus e to the negative t. And that would be my speed. And so that's all we would do there. Okay, let's try this one. You have an e to the t times cosine t plus sine t plus t. And so you could multiply the e to the t across if you wanted to, and make it e to the t cosine t, e to the t sine t, that sort of thing. Or if you leave it the way it is, you have to do it as a product rule. So let's either do one product rule or multiply it across and do multiple product rules. I'm going to just do the one product rule. And so my velocity is r prime of t. And so the product rule, I would do the first one times the derivative of the second. Cosine would go to negative sine t, I. Sine would go to cosine. And t goes to 1. Okay. Plus the second times the derivative of the first. The derivative of the first one is still just e to the t. And so, in fact, nothing changes on the second part. As far as that goes. And so then I would probably group them together. There's an e to the t on both of them that you can factor out. And this would be a cosine minus sine on the I. It would be a sine plus a cosine on the j. And it would be a 1 and a t, or a t plus 1 on the k. That would be your velocity. No identities here. Sine plus cosine, stuff like that doesn't do a whole lot. My acceleration would again be another product rule the way it's written. So my acceleration is r double prime. So I would do the first one times the derivative of the second. The derivative of the second one, the cosine goes to negative sine. Sine goes to cosine. Sine goes to cosine. Cosine goes to negative sine. T plus 1 would just go to 1, k. Plus the second time derivative of the first, again, will not change anything on the second part because the e to the t doesn't change. So we'll have the same negative sine t minus, oh, sorry, I'm reading the wrong one. I was reading the same same a function there for a moment. So I gotta go back to the v and say this is cosine minus sine times the I plus, I might have to squeeze this down on below that, plus the sine plus cosine on the j and the t plus 1 on the k. Again, we can group these together. There's an e to the t in common, so you can factor that e to the t all the way out front. I have a negative sine, a negative cosine, a cosine, and a negative sine. So the cosines would cancel on the I, and I'll have a negative 2 sine t on the I. On the j's, I have a cosine, and the cosine will make a 2 cosine. The sines are opposite signs, so they cancel. And I have a t plus 1 with another 1, which will make a t plus 2 on the k. And that would be your acceleration. As far as the speed goes, your speed would be the magnitude of the velocity. Now, the e on the outside, you could pull the e out front. That is okay. I probably should do that. That way I don't have to keep up with the e, the e all the way through the problem or anything. So Let's just pull that e out in front. And then I'll do the magnitude of the other part. So I'll have cosine minus sine squared, sine plus cosine, and then the t plus 1 squared. So the terms from your velocity function get squared and added together. Again, you can simplify this if you want, especially with all those sines and cosines in there. It will simplify. If you want to leave it like that, that is perfectly okay. If you do square it out, if you want to try to kind of simplify this a little bit, if you want to, this will turn into just t squared plus 2t plus 3. You just have to square it all out, and then your sine squareds plus cosine squareds become 1s, and other terms just cancel. So if you want to simplify it, you're welcome to. Okay, this one says find the velocity and position vectors. So we're going to go the other way around. So they're starting you off with the acceleration. Can you go back to find the position? This is just like back in Cal 2 when they started with you with an acceleration and you had to integrate it to get back to your position. That's what we will do here. So we're going to integrate this thing. So your velocity will be the integral of your acceleration. And so we'll have the integral of 2I plus 2tk. 2I plus 2tk. And so if I integrate that, the 2 just becomes 2t. The 2t will become 2t squared over 2, which is just t squared. Okay, and I'll end up with a constant vector. I can find that constant vector because I know the v of 0 is 3I plus j. So if I put v of 0 in there, that would be 2 times 0 on the I, and 0 squared on the k, plus the constant vector has to be 3I minus j. Well, plugging those zeros in, that's just going to wipe all that stuff out. So I'll get that my constant vector was the 3I minus j. So my velocity vector is 2ti plus t squared k plus 3I minus j. And then we like to group them together. So like for the I would say it's 2t plus 3I minus j plus t squared k. So that's my velocity vector. Then I could go another step and find the r. So the r would be what I got when I integrated v. So I'll integrate this 2t plus 3I minus j plus t squared k with respect to t. And so I'll get t squared plus 3 on the I. Sorry, not 3, 3t. Let the t off. The minus 1j will become minus tj. If you integrate the number 1, you get t. And the t squared will become t cubed over 3k. And then I'll get another constant vector. I'm going to call it d since I already used c already. And I can find that constant vector by plugging in 0 and using this r of 0 equals j plus k. So r at 0 would be 0 squared plus 3 times 0 on the I, plus 0, or actually minus 0j, but it doesn't really matter since it's a 0 either way. But just make sure, minus 0j, plus 0 cubed over 3k, plus your constant vector had to be j plus k. And just like on the last one, plugging in 0 is going to wipe out every one of these things. And so my vector d is just j plus k. And so my vector r should have been t squared plus 3t times I minus tj plus t cubed over 3k plus j plus k. And just like on the vector for the velocity, I would want to group them together. There's no extra i's in there, so I'll get a t squared plus 3t on the I. The j has a minus t and a plus 1, so I could either do it as factoring the negative out or leaving the negative in. It doesn't really matter. I'm going to make it as a t minus, or 1 minus t on the j, and then put a positive out in front. And then I'll have a t cubed over 3 plus 1 on the k. This would be my position vector for the particle. Okay, let's do another one like that, except now we're going to do it with 2t and a sine t and a cosine 2t. But the process is going to be the same. I'm going to start with the velocity first. And so to find the velocity, I'm going to integrate the acceleration. So I'm going to integrate the 2ti, the sine tj, and the cosine 2tk. And so that will give me a t squared on the I. Sine goes back to negative cosine. Cosine goes back to sine, but because of the 2 in front of the t, I have to divide by 2 or multiply by 1/2, whichever one you want to do. And then I have my constant vector, c that I'll call it in this case. And I can find that c value because v of 0 is I. So v of 0 would be 0 squared I minus cosine 0. Ooh, why did I put dt there? I have no idea. That's supposed to be j. I don't know. It's supposed to be a j. And it's supposed to be a k on that one. J plus 1/2 sine 0k plus c equals I. Well, in this case, cosine of 0 will not go away. Sine of 0 goes away, and the 0 squared goes away. But not the cosine 0. Cosine 0 is 1. So this will give me negative j plus c equals I. So c must have been I plus j, moving the j to the other side. And so your velocity vector would have been t squared I minus cosine tj plus 1/2 sine 2tk plus I plus j. But again, I'm going to group those together to make this a t squared plus 1. Those both have the I on them. I'll have a 1 minus cosine t on the j, and the 1/2 sine 2t didn't pick anything else extra up. So this is my velocity. And I can do the exact same process, integrating and everything, to come up with the position. So my position function, my r, will be integrating what I just found there, the t squared plus 1 on the I. That's pretty easy to integrate. The 1 minus cosine t on the j. Again, pretty easy to integrate. And the 1/2 sine 2t on the k. That's also fairly easy to integrate. And so I'll end up with a t cubed over 3 plus t on the I. I'll end up with a t minus sine t on the j. And sine goes back to negative cosine, so I'll get a negative 1/4 cosine 2t. 1/4 because I had to divide by another 2. And then I have another constant on the end. Plugging in 0, I can find out what that constant vector is. So r of 0 would be 0 cubed over 3 would be 0 plus 0, so I just get 0 and 0 on the I. On the j, I'll end up with a 0 and a minus sine 0, which is also 0. And then I'll end up with a minus 1/4 cosine 0 k plus d. That had to be j. Well, all of these zeros make all of this stuff go away, but cosine 0 is 1. So I'm left with a negative 1/4 times 1 k plus d equals j. So d must have been j plus 1/4 of a k. Plug that in, and because I'm about out of room, I'm going to go ahead and combine them all together in one step here. The i's didn't pick anything up with the d, so that will stay t cubed over 3 plus t on the I. The j picked up an extra 1, so I'll have a 1 that goes along with the t and the minus sine t on the j. And the k picked up a 1/4, so I'll have a 1/4 minus 1/4 cosine 2t on the k. And that is my position vector. And you could also factor out the 1/4 if you wanted to. Okay, one last problem. The position function of a particle is given by this equation, the t squared, the 5t, and t squared minus 16t. When would you have a minimum speed? And I'll actually go even further and say, maybe we even find that minimum speed. Well, speed comes from your velocity, so you got to find your velocity first. So your velocity is the derivative of your position. And so the t squared becomes 2t, the 5t becomes 5, the t squared becomes 2t, and the minus 16t becomes minus 16. And so that's my velocity. I'm looking for when my speed is a minimum, so I have to find my formula for my speed. So speed is the magnitude of the velocity. So I have to do 2t squared, 5 squared, and 2t minus 16 squared. Now in this case, I will want to simplify this, and I'll tell you why in just a moment. So let's see what happens if I try to simplify just a little bit. This is 4t squared, this is 25, and the other one is a perfect square, so I would square the first one, which would be 4t squared. Multiply them together and double it. 16 times 2 is 32, doubled is 64t, and 16 squared is 256. So I'll get 8t squared minus 64t, and then 256 and 25 is 2, 5, 6, 7, 81. That's my speed. Now, because I'm looking for a minimum on the speed, just like you did that in Cal 1, if you're looking for a max or a min, you took the derivative and set it equal to 0 to find any critical values. Well, that's what we're going to do here. My formula that I'm going to be using for it is my speed. So I'm actually going to make this say 8t squared minus 64t plus 281 to the 1/2 power, because I need to take the derivative of that. So I need the derivative of the speed function over time. That would be to pull the 1/2 down, leave the inside just the way it is, to the 1 less power, times the derivative of the inside. 8 times 2 is 16t minus 64. And so I could do the 1/2 times the stuff in the back. 1/2 of 16 would be 8t, and 1/2 of 64 would be 32. And I could divide that, moving the radical, the 1/2 power back to the bottom, making that be 8t squared minus 64t plus 281 back in the denominator. So I want to know where that equals 0. Well, the top part being 0 would be the number that made the whole thing 0. And so 8t minus 32 equals 0, which means 8t was 32. So t was 4. So as long as 4 doesn't make the bottom 0, then 4 is your answer. And you could check it, it won't make it. So when does it occur? It occurs when t equals 4. So if you want to go one more step and say, what would that speed actually be? You can find the speed just by plugging that back into the speed function. And so the actual speed when t equals 4 is 8 times 4 squared minus 64 times 4 plus 281. That comes out to be the square root of 153, or a little bit more than 12. So whatever the speed's measured in, whether it's in miles per hour, feet per second, whatever. And so hopefully that makes sense. And that is the end of Cal 3. So I hope you enjoyed it. I hope you learned something. And hopefully Cal 4 goes well for you as well if you're going towards Cal 4.